Good morning, everyone. How are you? Thank you for taking the time to attend. I know it's not easy with your busy schedules. It's great to be in this lovely institute, which I'm a member of. I don't get to come here as often as I would like due to work commitments, etc. But thank you all the same. Just as a bit of a courtesy, I just want to extend my sincere thanks to Shay and the staff for putting this professional presentation together today, and thank you for the invite to present to you all. I was given a brief just to discuss with you certain changes or to discuss IS 3217 and IS 3218, but as you can appreciate, they're very broad standards. So what I thought would be a nice way of getting through, say, 30 minutes or so, would be to discuss the areas of change. And those are the areas of change between the 2008, 2009 up to 2013 standards. In conjunction with that, as I was putting the short presentation together, I just thought it would be nice to have a little bit of a discussion on the area of VADS. Because VADS is, although it isn't legalised, if you like, if we use that term within IS 3218, it certainly is now part of BS 5839. And going back to what Paddy was just talking about, the harmonisation of standards through CPR, there is now a European requirement or standard known as EN 5423. And EN 5423 basically deals with manufacturer requirements. What are the requirements by a manufacturer to put a VAD onto the marketplace? And basically, that means a VAD is a visual alarm device. The reason I decided to talk about this little subject because it fits in very nice with the fire alarm, which is inevitably is going to hit our shores, because like our cousins across the water in the UK and Europe, we tend to follow suit, maybe 12 to 18 months hence down the road, but we tend to follow suit thereafter. So just very, very brief, I won't bore you, we'll get through the presentation. 3 categories: VADS, fire and emergency lighting. The aim, as we know, of a fire alarm system is to warn people of a possible emergency. We understand that the normal way of doing that is through audible units, known as sounders, bells, etc. But the ability to hear can be impaired vis-a-vis disability, etc. So disability, masking of other loud noises, so factory scenarios, all the way down to personal music systems, etc. So you can appreciate that there are a variety of reasons why audible solutions are not the only solution. So this is where visual, and we accept, however, although I'm here just to talk to you about VADs, we accept that that's not obviously the only option available to today, because obviously we've tactile devices, etc., as we are very much aware of. So I just wanted to briefly discuss about EN54, and thank God for Paddy was there, because Paddy discusses the standards far better than I do. But basically CPR, there was a document put together by manufacturers in the UK prior to 2013, but that particular standard was harmonised, and then that became under CPR, that became EN 5423. So we all know and we're all aware of the EN 54 for EN 54 part 1 all the way up. It deals with smoke detectors and panels and detectors, etc., all the way up, and now we have EN 5423. So it has specific, if you like, consequences for the manufacturer of all of these devices. So what I'm going to really talk to you about is, what does that really mean? What are we talking about? We're talking about a set of criteria that all the manufacturers, because there are many, that they really have a common platform that they're going to operate off. So then I just wanted to briefly discuss the whole area. That's all very well that we have a standard, and it's EN 5423, and that's to do with the manufacturers. Well, what about us guys? What about the guys on the front lines, the guys on sites, etc.? What is the code of practice? Is there a code of practice? Yes, there is now, and that was adopted into BS 5839, and that's called COP 0001. So throwing a few numbers at you and etc. But EN 5423 is a manufacturer's design standard. and the COP 0001 is actually the field implementation. So just if you like expand on that, what is COP 0001? Well, it's actually, as I just said, that field implementation of the standard of VADs, and that relates, to the areas of planning, design, installation, commissioning, maintenance, and as I was talking about earlier about things going to happen here in the next 12 months to 18 months, I say that with a little bit of experience. I sit on the working committee of IS 3218 with so many learned colleagues from across the industry, and you can always see it. A few years later, if we see something that's happening in Europe or whatever, it inevitably is adopted into the IS standards. So you can see this was led by FIA and LPCB. But basically speaking, just a little bit of recap, EN 5423 is a manufacturer standard, and COP 0001 is the implementation of that for us guys on site. So what does that basically mean? So what do the manufacturers have to do? Well, the manufacturers have to do, they have to give us a minimum criteria of what they're going to adhere to. And that means 1 candela in any direction, maximum 500 candelas, obviously, to prevent glare, and that has its impact across the emergency lighting spectrum as well. Flash rate 0.5 to 2 hertz, and obviously that has health implications because we have people with different conditions, so the flash rate is very, very important. The flash colour is white or red. It's uniformed now. Defined of 3 categories. So it's nice and easy. It's a straightforward standard. You're going to have a wall, you're going to have a ceiling, and then you're going to have an open. So what do we mean by that? Just to clarify, we've seen beacons for years. We've seen them on walls. We've seen them on ceilings, and it tends to be, the rule of thumb used to be 10% for people of disability within any premises. If it was a hotel, you cover 10% of your rooms, and you would make sure there was tactile devices, or you would make sure that there was, visual alarms, etc., in those rooms for an allowance of people of disability. But now, with the implementation of EN 5423, an old beacon is literally just that. It's just there as to draw someone's attention. It is only a beacon. It doesn't encompass a room. You can just see it off in the distance. So, what do we want from our EN 5423? Well, what we want is that, as I said, it covers a volume of an area of a room. A volume, that's what we're looking for. Because as designers, if it's smoke detection, if it's emergency lighting, if it's lighting, we like to play by a set of rules. And the conditions are, this fitting will give me a certain amount of lumen output. Therefore, with the spacing of that and the space to height ratio is this. So we have a plan, and we know how to put a system together. Likewise in a VAD, we again adopted some figures from our cousins in the US, and that particular level is 0.4 lux, or 0.4 lumens per meter squared as it's measured. And again, that was taken from the US, and they've been using that particular figure for many, many years, and it's deemed to work very, very well. So when we talk about using VADs, we talk about a uniformity of 0.4 lux in an area. But the nice thing about VADs, as I'll continue and I'll talk to you about, is the 3 categories. So we appreciate that design isn't always as straightforward as we would like. Vis-a-vis, listed buildings, we certain restrictions on ceilings, etc. So we may want to put on a wall, and vice versa, we may just want to put on the ceiling. So we've wall, we've ceiling, and we've open. What do these really, really mean? Well, wall and ceiling, they have a specific dispersion height, and which I'll give you an example for now, whereby an open one, they can be designed, believe it or not, you can actually contact a manufacturer of a VAD and say you have a specific requirement. You have a very oddly shaped room, shaped area that you want to encompass an EN54 compliant device into. So, perfect example. Today, we like to work off certainties, as I said. If it's a smoke detector, we like to know that it's 10 by 10. It covers an area by 10 by 10. We like to know that our 1 lux down our centre line in emergency lighting or whatever. So, it makes design that little bit easier. Similarly with a VAD, VADs now come with a set criteria. That the criteria is, for example, it says W2.46. So that's actually going to be written on the box. Or a different criteria. It might be W2.4, 8, 10, whatever the requirement is. But this is just a perfect example that the minimum height of a wall VAD is now 2.4 meters. And the area it's going to cover is 6 by 6. Now that's great, isn't it? Because you have certainty now that depending on the size of the room will determine how many of those VADs you're going to use in that room. So it's very, very straightforward from a design process. Similarly, I'm just giving you a comparison here on the ceiling. You've C, 3 and 6. So it's C for ceiling mounted, it's 3 meter height, and that's a minimum, and then you've got a 6 meter coverage. But that is obviously in a diameter. So, via the math you can calculate similarly as you do in smoke detection, you can work out your grids. So you know then how to work out your system. So like a 6 meter diameter will give you a 4.2 meter square. So which you, as I said, I gave you a perfect example, as vis-a-vis smoke detection works in a very, very similar way when you're doing that design process. So just kind of summing up revision points, which will help us. What is EN 5423? Well, it is now a regulation, a mandatory regulation for manufacturers of VADs. So they have a set criteria. It doesn't matter who you buy from, but they're all reading off the same hymn sheet. Okay, the volume, the minimum volume that they must adhere to is, as I said to you earlier, taken from our cousins in the USA, and that is that 0.4 lux. That is a crucial figure to remember. And all the information that I've just spoken to you about has to be detailed on the box. So it's very, very straightforward. So the W2.46 or the C36, etc., be it a wall or whatever, ceiling mounted, it's all now written on the box for you. The flash rates, which I went through earlier. And then, of course, COP 0001 is the field implementation of that. So that really just gives us a flavour. Now, obviously, like Pat and the other contributors, Michael, we could talk an awful lot more about that particular area. But I think if you walk away today with the knowledge that VADs are coming down the road, they're not in IS 3218 yet, but they will be. It's inevitable because it is a lovely platform for designers. It's an easy platform to use. Vis-a-vis up to now, you would have a beacon on a wall. It just flashes. It doesn't do an awful lot. It really just doesn't do an awful lot. It might get your attention, but now with the strict guidelines of design, we now know it will fill a volume of a room. COP 0001 is the field implementation of that standard, and I've given you a couple of examples of it. So if you leave today knowing what EN 5423 is and COP 0001, we'd be delighted. So moving on to the area of fire alarm and emergency lighting. These are areas that I'm involved in for many years, 25 or more, and I get a bit passionate about them, so I'll try to dumb it down and again just hit you with the points of change over the course of 2008, 2009 up to 2013. And what I've tried to do so it'll make it informative for you and to the point so we don't dilly-dally are literally the changes. So the inclusion, which is a nice inclusion I think, is the issuing of false and misleading information is an offence under the Fire Act Services, section 22. That's actually been added into IS 3218. Why? I suppose to give it a little bit of meat, give it a little bit of more of an impact, because we all know that there's rogue installers, people around the country, across Europe or whatever, that may not adhere to the standards that we would like. So we've kind of put this into the standard in the hope that that will prevent, stop if you like, any further, misgivings or any further inaccuracies in documentation. So the first area of change is under the audible and visual alarms. So Vis-a-vis up to now, we've been talking about that there should be a minimum of two sounder circuits from a fire alarm system used. Although that was great, you would have certain people that would wire all the internal circuits in a building on circuit 1, and then they would wire circuit 2 outside. So practicality tells you, if you're a good electrician, if you're a good engineer, we always talk about redundancies of different type, redundancies as in transformation, or redundancies of networks or service or whatever. And similarly at this lower level, when we're talking about sounders, if we only have one dedicated sounder circuit within a building and a fuse is to blow or the circuit is to go, or you have a short circuit in that, well, obviously it's going to tell us that that really isn't best practice. So what we've tried to do now is point out that we require a minimum of 2 sounder circuits in the building. Not a huge point, but it makes a big impact. Auto silence. Yeah, this is an area that's kind of, again, with our cousins in the intruder industry. For many, many years, from 1989 up to 2009 or 2008 or 2009, we didn't have a limitation on the external sounder strobe off the fire alarm system. But yet our intruder colleagues did. And it made sense. You see, all of this information that I'm relaying to you when I sit on the working group, and Pat will tell you the same, is submissions from people like your good selves. You write in and you say, you know, this particular point doesn't make sense to us. Our proposal is as follows. Will you take this on board? And inevitably, over the course of from 1989 up to 2013, that's exactly how the standards actually changed. From people like yourselves making an impact to the standard itself. So we've brought down the external sounder strobe element down to 15 minutes. Not a huge impact on the maximum sounder level. They say you will have hearing impairment, temporary or otherwise, at 126. So 126, if you're exposed to anything above 126, you're going to have some difficulties. You'll all have experienced that situation where you leave an area of high volume, and either you get this dullness in your ear or you get that ringing in your ear. That normally is only temporary. But you take an individual that's working in a factory, he has to wear ear defenders now for obvious reasons, because you can get certain medical conditions down the line. And the whole area of sound levels and sizes of room, up to now, it used to be, you know, your standard 65 dB plus or minus 5% and 75 dB for sleeping accommodation, etc. But what we've tried to do in the whole area of the sound is say, well, listen, if it's a very, very small area, up to 25 meters squared, so you can see my both axes there, the X and the Y, and you've got the dB level on the left-hand side there, you'll see that the requirement is still 65. What we're saying is we're going to make it above 25 meters squared. So any room above 25 meters squared, we're going to bring it up to the 65. And again, that came from our cousins in UK and Europe as well. We just harmonise it in our own standard. With emphasis on campus sound, the one that jumps out at me is something like UCD or something like that. You might have 20 odd buildings more, and they all have a different manufacturer of a fire alarm in it. They might have, some of them might be, 15, 20 years old, some of them might be a year or two old. Some might have bells, some might have sounders. Common sense tells us now that we don't use sounders and bells within a premises. So it makes common sense to take that right through and say, well then, if we're talking about campus, we don't want conflicting noises either on a campus site. So very, very straightforward from that point of view. So again, going back to my first presentation, which was on the VADs, just to say it's not mandatory in IS 3218 at the moment, but like anything, it will be in the future. Technically, Document M requires a VAD for disabled toilets, and if the use of a VAD is determined for a reason of disability, then the product must be EN 5423 compliant. So that leads me on to the area of manual call points. Few little changes within the call point arena, and that is mounted at all exits, not exits to open air. That may seem like a silly one, but how many times have we gone to a premises and there is an exit out into a small courtyard? Well, that is no good to anybody. You know, in the event of a fire, we don't want people in a small courtyard or where they can't get access to the public roads. So we just redefined that to say that all exits, not exits to open air. Exits defines as a point of safe dispersal. Undefined escape routes and not designated escape routes. Again, just slightly subtle change. In each refuge area, again, refuge systems are becoming more prevalent, not directly in our technical documents as yet, but certainly in the UK it is a requirement. But as our whole discussion is about standards and standards, how they're evolving, it makes complete and utter sense to have a break glass unit in a point of refuge where a person of disability, if they sense that there's an issue that they need to bring to the attention of the fire services, they can hit a break glass. In story exits, I think this is a nice change. This came about over a number of years of discussion, mainly in the area whereby, if we give you an example, a 4, 5, 6 story building, you know, a chap runs out, John runs out of the 6th floor. He runs down the back stairwell and he's running down. Halfway down he goes, oh, there's a fire. I'll hit a break glass. And he hits a break glass and he goes down to the exit and he leaves. Fire officer arrives, fire brigade arrives, and they look and they say, it's zone 3 lads, everyone up to the 3rd floor. So it doesn't really work like that. So now what we're doing is we're putting exits inside story and outside story. So you'll never get break glasses absolutely right. You'll never get them exactly right. But we're trying to make sure now that at the end of each corridor, the story exits, that we've exit positioned there as well. Now, there is a matrix, which I didn't want to baffle you about, but to supplement that, there is now a matrix of for the location of break glasses within high-rise buildings. So it doesn't really affect us maybe as much as it should do now, insofar as we're limited really in the amount of large-scale buildings we have here in Ireland. But, you know, that's probably going to change in the future. Smoke detectors and smoke detection in itself. A small adjustment on the aspirating side, 10.5 metres up to 12 metres. And that's just to do with aspirating systems, so minor change there. Wall mounting, allowable of L3 adjoining rooms. Just to give you a bit of background for those people who aren't familiar, when we're talking about an L3 certificate, we're basically talking about rooms that open up onto an escape route. An escape route being an L4 certificate. So our starting premise of any design is the coverage of automatic smoke detection, an automatic system on an escape route. We classify that as an L4 system. Any room directly opening up onto that exit is classified as an L3 room. Many times when we're asked to go in and look at different projects, you find that if it's a listed building, for example, you find that you're limited in the amount of positions and installation cable runs that you have at your disposal, because you're inevitably on your right shoulder you have a conservational architect on your right hand side and someone from the council on your left hand side, so it can be a very dodgy territory. But to take that into the realms of fire, what we've said is that in certain cases, and only certain cases, an engineering proposal is put forward that makes sense, we'll allow the wall mounting of a smoke detector within certain rooms, but it must be with a big but. And that is that it still meets the requirements of that detector. Vis-a-vis, it shouldn't be over 10 by 10. So, which again makes sense, because obviously the activation time would be vastly reduced if the fire was at the far end of a room that was larger than 10 by 10. Detector sighting, light wells. Again, just minor changes here, nothing huge, but what we're requiring is in a light well, yes, we want a smoke detector in a light well, but only under the condition, unless the total area of the light well is less than 10% of the total area of the protected ceiling or area. So that kind of makes sense. If it's a very, very, very big ceiling and a well in comparison to it is less than 10%, you don't need a detector in that area. Toilets, lobbies less than 2 meters squared, which is an increase because toilet lobbies, those little tricky areas between the corridor and a toilet, or the corridor and an office or whatever, that little airlock used to be less than 1 metre squared. You didn't need to put detection in. We've just increased that up to 2 metres squared. But again, common sense provided, and what we say is risk assessment. Risk assessment is the buzzword in IS 3217 and 8 these days. But, you know, if there's a large fire loading in that area, well, then common sense will tell you it's in there. But if it's less than 2 metres squared, there's not going to be huge fire loading. Right, voids, again, just clarified within the document to say that we're talking about horizontal voids. Greater than 800 millimetres, we would treat them as normal open spaces and cover them accordingly. Greater than 800 millimetres, all voids are on an L1 category, unless an assessment, so a risk assessment again. If a risk assessment deems it not necessary, well then, you know, you put that argument forward. But it must be noted as a variation on the design cert. Less than 800 metres. Back in 1989 times, it was simple. It was, if it's less than 800 mil, you don't put a detector in. If it's over 800 mil, you just treat it as an open area. But today what we say is that if it's less than 800 mil, we would like you to do a risk assessment. Again, on the fire loading. Is the potential of a fire happening in that void and a potential for it to spread horizontally across a building? If it is, you put a detector in. So that kind of makes common sense. Miscellaneous changes. 20% increase in standby capacity. It's not something we'd all pick up on, just geeks like me. Beams. Used to be a case that you'd have a fire beam, and the maximum manufacturer would make them was 100 metre. So that was obviously written into the standard. But you can now get beams from 150 up to 200 metres. So obviously we've just made that change to correspond to that. With regard to people of disability or special needs, what the new requirement is that there is a repeater panel or a network panel below the normal mounting height of a fire alarm panel. And that again makes sense. I came in on the Dart this morning. I haven't been on the Dart in years. It was great. And the first thing I noticed was the button to access, you know, to open and close the doors, etc. Plus in intercom is at a much lower level than the other button. So what I'm trying to say is that common sense always prevails. And a lot of the standards that we deal in are dealt around the area of common sense. So again, that covers just the 90% changes of the changes between 2009 and 2013 in the IS 3218. So thank you for your attention on that. Last area of interest is emergency lighting. Again, an area in which I've been involved for many years and quite enjoy. So again, when we were putting the presentation together, just thought it would be ideal just to emphasize those, you know, those changes. And again, changes are built around common sense. New installations, it's an obvious one, must comply to IS 3218 or 17 2013 in full. That's a no-brainer. Existing installations, used to be the rule of thumb vis-a-vis fire alarm emergency lighting was, if a building was 20 years old, 10 years old, whatever the case may be, and it predated 2008, it operated under 1989 regulations. And it probably had its original fire certificate. And the rule of thumb was, if it was issued, the fire certificate was issued back then, well then the life safety systems within that premises would only have to adhere to that fire certificate. But what we've done now is that a subtle change, only a subtle one, to say that existing buildings that have a particular fire certificate but also have emergency lighting, what we would like you to do is to adhere to the checklist. So we brought out 3 definite checklists for you. So whatever age the building it is, it fits into that checklist, and we would like you to adhere to that checklist. So that's on testing procedures, etc. Now, the transition period, this again just goes to support the argument I was just making. For new installations, if a fire certificate was granted previously, previous version of the standard, no need to upgrade. But what we would like you to do is adhere to that checklist. And you'll see that in the standard. It's a much better document this time around than, let us say, maybe in a previous incarnation. But this is the nice bit we've added to it, that even if it predates, say if it's under 1989 regs, what we would like is that the user and say a service provider, we would like them to operate to 2013 standards where possible. So again, what we're just trying to do is bring people with us, bring them with the standards, not hammer them for the sake that they don't have them, but try to bring as many people with us as we can. So huge, I'll just pop these all up. This is quite a significant one, and is there one more? There is. So first aid kits, firefighting equipment, fire alarm panels, call points vis-a-vis break glasses, refuge points, and lighting support switchboards. I suppose in a way you could say this is all make common sense, but they've really introduced this 5 lux rule. And the 5 lux rule basically supports consulting engineers, designers like yourselves, to emphasize points of life safety. So if we're looking at this imaginary corridor, when we're looking down it in an emergency scenario, we're looking down the center line and we see a 1 lux level. We hope that there isn't a differential of 40:1, a ratio of uniformity. That's what their standard calls for. But what we should see is pockets of higher illumination. So as I say, it's a very simplistic way of looking at it, but if we're looking at that corridor, we should see those pockets. So a break glass, an extinguisher, a first aid kit, etc., that they're highlighted to a much higher lumen output than is required for the center line. And I think you would agree that makes common sense. A couple of changes to lift cars and lift shafts themselves. The new requirement now states that you need obviously 1 in the car, 1 on top of the car, 1 on top of the shaft, and in the lift pit. Again, previously we were only taking care of the people in the car. We weren't taking care of the people who were maintaining the car. So obviously this is a little bit of a common sense, and again a point that it was adopted from a submission from a member of the industry, let us say. So toilets and lobbies. Okay, prior to 2008 it was a very simple rule. If it was 8 meters squared and less, you didn't need an emergency light. And anything above 8 meters squared, you required an emergency light. But now the standards have slightly changed, and what we've said is that if it's a toilet and it's open to the public or whatever, we want an emergency light no matter what the size of it is. But again, I didn't bring you the actual, there's a lovely schematic inside the IS 3217, and it details the different categories within a typical, if you like, a typical large toilet. And that you might have a changing area for a changing room for a baby. You might have a disabled toilet within that area. You might have the main open area. And they operate off different levels, 0.5 to 1 lux. Again, there was a whole, people were very, very confused about the level. Could you use an exit sign? Could you not use an exit sign? Is an exit sign actually an emergency light? No, it's not. Can I use the output from it, etc.? So what we've said is that, firstly, we want an exit sign in a toilet, a large toilet, that has any kind of ambiguity. So if there's many doors, if there's many cubicles and they're sealed up to the roof and you've got the main door, may sound very simplistic, but what we're saying is we need you to differentiate those doors and put in an exit sign. But what we are saying is, in that particular scenario, you're able to use some of the light off the exit sign. Toilet lobbies, again, less than 6 meters squared. The rule, again, is a very simple rule for emergency lighting as regards, if it's less than 6 meters squared, or should I say, if it's over 8 meters squared, if it's a very simple rule. You need 2 emergency lights and relevant exit signs. And the rule of thumb there is, obviously, due to the spacing tables or the manufacturer's spacing tables, it'll determine whether that's 2 or 3 or whatever. But if we take it as a minimum level and we're talking about 2, that's what the requirement says. Again, there's a little bit of redundancy in there, isn't there? If one goes, you still have another one. But in areas less than 6 meters squared, what we've said is that second emergency bulkhead, downlight or whatever it is, or conversion, internal conversion, we're going to allow you to use the exit sign. So to get over that whole area of those 2 emergency fittings, less than 6 meters squared, you can use 1 emergency fitting and you can use the exit sign as the second. So toilet lobbies less than 2 meters squared, spill through. Again, it's not a place you're going to get lost in. So that little lobby, you're going to open that door, and if you spill through from the actual toilet or spill through from the actual escape route, we're happy with that. It's not necessary in all cases that you will require an emergency light. That is not to say that we're saying you don't have to put it in. We're just saying you're a little bit more lenient on it. The whole area of competence. This is a very interesting area because people tend to get their backs up when someone says they're competent or incompetent, but we won't use that word today. But the whole area of competence and how to define or how to demonstrate your competence in a particular area is, it's a tough one. But what we hope to do as designers is prescribe way that you can demonstrate it. So firstly, I want to explain that if anybody sitting here today deems themselves competent, firstly, I'm not going to contradict them. But second of all, they're only going to put themselves up on that mantle if they know the information. Because you'll be found out very, very quickly if you don't know the information and you set yourself up there, certainly as an expert or a leader. So what we're saying is that designers of emergency lighting can be chartered engineers. And that goes without saying. The reason we say chartered engineers is because chartered engineers have a lifetime of experience. They've seen most of every project that there is to see. So we say chartered engineers, no problem. Professional engineers, what we're saying is, again, another competent part of our industry, but what we're saying is ways of demonstrating your ability to design is either have vast amounts of emergency lighting design experience, or you can finish a level 6 award or a level 6 course in emergency lighting design. So which there are many out there today. But so it goes back to competence. At all stages, if you say you're competent and you can back that up with the correct information and you do a good design, that's perfectly fine. But if you're called upon to demonstrate your competence, these are the ways that you can do it. Same in the commissioning arena. So if we're out in the field, what we're looking for is that we designate that an employee of an emergency lighting company as a person of competence because they're working within that arena. They know the equipment, they know how it works, etc. So we deem them as the people of competence. But if they're not, or they want to emphasize that or support that experience, what we're saying is you can do a level 6 as well in commissioning. Vis-a-vis 2008 didn't have sample certs for whatever reason. The plethora of certs from design all the way down to report and annual test are now available in the back of IS 3217. So all we're asking for is that, industry, contractors, installers, just adhere to the actual layout of those certificates, put their letterheads on top of them and follow. In that way, what we have across the industry is uniformity. Prior to this, we had kind of this haphazard issuing of certs, which weren't really, it didn't offer up a very professional image of our industry. And that, my friends, is that. That covers the area of VADS, IS 3218, the changes between 2009 and 2013. And that is emergency lighting changes from 2008 to 2013. And I want to thank you so much for your attention, and hopefully I didn't bore you too much. Thank you.